Applying Lechatelier's principle to the Haber process. In the industrial production of chemicals, it is important to produce the product in the least possible time and at the lowest cost. The Haber process is the industrial process used to produce ammonia, which is used in fertilizers. The chemical equation of the reaction is given by N2 gas plus 3H2 gas, reversible reaction giving 2NH3 gas. Delta H equals negative. Let us analyze the effect of each of the factors that affect equilibrium. We require the highest possible yield of NH3 in the least amount of time. The forward reaction needs to be favored, as the equilibrium mixture will then contain more concentration of NH3 and lesser concentration of N2 and H2. Pressure. The number of moles of gas on the product side and the balanced chemical equation is lesser than the number of moles of gas on the reactant side. When pressure is applied on the system responds to the stress by shifting the equilibrium position such that there are more products than reactants. That is, higher pressure favors the forward reaction. This reduces the number of gas molecules and hence the pressure. This gives a higher yield of ammonia. The pressure that is applied in the industrial process is 200 times the atmospheric pressure. Further increase makes the cost greater than the financial gain from the higher yield of ammonia. Temperature. The forward reaction is exothermic. To favor an exothermic reaction, the temperature must be reduced, to which the system responds by favoring the reaction that increases the temperature. Reducing the temperature favors the forward reaction. However, temperature also affects the rate of a reaction. At low temperatures, the reaction takes extremely long to reach equilibrium. This is not ideal for industrial production. Therefore, a temperature of around 550 degrees Celsius is maintained in the reaction vessel to speed up the reaction. The high temperature causes the yield of ammonia, concentration of equilibrium, to be low, since the reverse reaction is favored, concentration. The use of high temperature favors the reverse reaction, so the concentration of the product is kept low by removing the product as it is formed. This ensures that there is very little NH3 to allow the reverse reaction. It also drives the forward reaction. The addition of N2 and H2 continuously also favors the forward reaction. Catalyst. A catalyst does not favor the forward or the reverse reaction. It speeds up both the reactions. A catalyzed reaction will achieve equilibrium much faster. The catalyst does not affect the yield, that is, the concentration of NH3 in the equilibrium mixture. In the Haber process, an uncatalyzed reaction will be extremely slow, increasing the cost of production. Therefore, an iron or an iron oxide catalyst is used.
Starting to feel it? Now go master it with Maski.